Hey, welcome. Let's finish up 1-1 practice and problem solving for 6th grade math Envision. It says, okay. All right. This is Hudson, guys. Hudson's going to show you a magic vacuum.
Yeah, it's right here.
He loves vacuums. All right, Hudson, we got to do some math. Use the graph to solve. A table tennis ball that has been hit is about 13 and 37/100 times as fast as the speed for swimming. All right, yeah, come on up. Show this and then go upstairs. What do you think?
Good.
All right, going upstairs and watch some, uh-oh, his magic vacuum broke. That's okay. You're okay, right? Sorry, Huddy.
That's okay.
Oh, sorry, buddy. All right, here we go. So we click that icon, and it's 13 and 37/100 times as fast as swimming. So swimming for me is 5.28. All right, so here we go. 13.
Have a nice day.
Thanks. You have a nice day as well.
Okay. I'll see you later.
I'll see you later.
Your magic vacuum's coming.
Oh, thank you, Huddy. 13 and 7/100 times 5.28. 5 and 28/100. 5. No thanks. You hold on to it until I'm done doing this.
Okay.
All right. So 4 digits times 3 digits. Okay, thanks. So we go 8 times 7 is 56. 8 times 3 is 24. Plus 5 is 29. Carry the 2. 8 times 3 is 24. Plus 2 is 26. 8 times 1 is 8. Plus 2 is 10. All right, now we've already used the 8. We've already used the 5. We've already used the 2 and that 2. Now I add a placeholder 0. Put a little smiley face in it. 2 times 7 is 14. 2 times 3 is 6 plus 1 is 7. 2 times 3 is 6. And 2 times 1 is 2. Now, we've already used that 2 and that 1. Now, when we do that 5, guys, we got to add 2 placeholder zeros. I'll put little smiley faces on them, okay? 5 times 7 is 35. How do you want to go upstairs? 5 times 3 is 15. Plus 3 is 18. 5 times 3 again is 15, plus 1 is 16. 5 times 1 is 5, plus 1 is 6. All right, now we'll add up all those partial products, hopefully with Hudson distracting. I didn't make a mistake. 6, 13, 7, 14. 14 plus 5 is 19. 1 plus 6 is 7, plus 8 is 15. 1 plus 1 is 2, plus 2 is 4, plus 6 is 10. And now there are 2 places behind the decimal here. 2 places behind the decimal here. 2 plus 2 is 4. It's a little magic there for you. So we go over 4 places. 1, 2, 3, 4. And let's see if this is correct. Okay, guys? Please be correct. 70 and 5,936 10,000s. Oh, thank goodness. I thought with our little distractions, we might not get it right, but we did. Hudson's still here.
Uh-huh.
Yeah, you're still here?
Yeah?
You don't want to watch TV with Cross?
I'm fine.
Okay.
I'm going to watch you.
You're going to watch me?
Yeah.
All right. Which activity has a speed about 7 times as fast as the rowing speed? All right. 7 times the speed of the rowing speed.
It's disappeared. See?
Oh, very good, Hudson. So the rowing speed is right here at 13 and 73 hundredths. And we want 7 times that. Oh, what? Hudson's over here doing magic. So what my goal is, guys, is I think it's either going to be luge or throwing a baseball. So what I'm going to do is go seven times the rowing speed. Rowing was 13.73.
Look, it disappeared, Dada.
So
Look, it
13.
disappeared, Dada.
Oh, cool. That's neat, Hudson. 13.73. 13.73 times 7. And I'm going to see which one's closest. Okay, guys? 7 times 7, 51. 21 plus 5 is 26. 7 plus 2 is 9. So 2 places over. So which one's close? So look, the 96 and 1100ths is, well, exactly 7 times as far. So that was, guys, the luge. The luge, whatever that is. What is luge? Let's see if the luge is right. It is. Ta-da. All right, guys, rocking and rolling, finishing this up. Huddy, we're rocking and rolling here. Tanya bought a blanket for $37.19, a pillow for $12.25, and a baseball cap for $14.75. She paid $50, and the rest she borrowed from her friend. If Tanya got $5.81 in change from the cashier, how much did she borrow from her friend to pay for all these items? Tanya borrowed how much money from her friend to pay for all these items? Okay, so Tanya's borrowing money to pay for this, guys. And Tanya got $5.81 in change, but we don't know how much she borrowed. She paid $50, and the rest she borrowed from her friend. So how much did she borrow from her friend? Well, we're going to take the change and add the items in as well. So we're going to add up those 4 numbers, and then we're going to subtract them from 50. All right, here we go. She paid. So she paid $50. So the price was more than $50. So we're going to take this total of these 4 numbers and subtract 50, and we'll get what the friend borrowed. $37.19. When you add with decimals, you want to line up the place values. Basically line up the decimals. So I'm doing that now. Here we go. So 5 and 5 is 10, plus 1, and 1 and 9 is 10, so that's 20. I like when you can find 10 pairs. 10 pairs is a great tip. 2 plus 1 plus 2 is 5, plus 7 is 12, and then 12 plus 8 is another 20. Here we have 2 plus 7 is 9, plus 2 is 11, plus 4 is 15, plus 5 is another 20. Notice I had that decimal there. 2 plus 3 is 5, plus 1 plus 1 is 7. So $70. So now what we have to do, guys, is go $70 minus the 50. 70 minus 50 is what? And then yours might be different than mine. So $20 left. Annabelle's time for a race was 28 and 6/10 seconds. Another runner's time was 9 and 89 hundredths of a second. Faster. So it looks like subtraction here. Write and evaluate an equation with a variable to find the difference between Annabelle's time and the other runner's time. An equation for the difference between the times is, so whenever it's saying equation on here, they're wanting an equal sign, okay? And there's some fine print in this question that you should see, and it's hidden in here. So I've had to help my students with this. So this is the fine print. Okay, read the fine print. Use operation symbols in the math palette as needed. Type an equation using A as a variable. Now, I just thought that was an A at first, but it's using A. I wish they put like quotes using A as a variable. Use whole numbers or decimals for any numbers in the equation. So what they're wanting here is they're saying the time Annabelle has 26 or 28 and 6/10 of a second minus A minus the other runner, which is unknown. That's a variable A. Is this much faster? 9 and 89 hundredths of a second. So an equation has an equal sign, and that's what they're wanting right there. So the other runner's speed was, well, we're going to solve this equation. So we're going to do 20. We're going to do 28 and 6/10 minus 9 and 89 hundredths. We got to add a placeholder 0 there. Can't do 0 minus 9, can we? No, we got to borrow. So 10 minus 9 is 1. 5 minus 8. Can't do that either. You know they like making us borrow. 7 minus 9. Nope. 17 minus 9. Yeah, we can do that. That is, of course, 8. So $18.71. Or 71 hundredths of a second faster. Or the other runner's time was 18 and 71 hundredths of a second. Okay. And we're almost done here. Explain why 25 hundredths times 8/10 has only one decimal place in the product. So if you can see here, 25 hundredths has 2 places, and this has 8/10 has 1 place. So 2 plus 1 should have 3 places behind the decimal, but it doesn't. It only has 1 place. Well, let's see if we can figure out why. So whenever they do these type of questions, what I recommend is to actually do it out and see if we can explain it. So you don't have to line up your decimals when you're multiplying here. That's 40. I think it has something to do with the 0. 8 times 2 is 16 plus 4 is 20. And then 3 places over. Now look, 200 thousandths equals 2/10 with only, what is that? 1 place beyond the decimal. You see what's going on here? So let's read these answer choices. The first zeros in the product do not change the value of the number. The zeros in the middle of the product do not change the value of the number. Well, yes, they do. If there were zeros in the middle and it's surrounded by 2 other numbers, it definitely, you can't remove those zeros. The non-zero digits in the product are the only ones that should be counted. Well, that is true in this case. The final zeros in the product do not change the value of the number. Yes, see these final zeros? These 2 zeros in the product don't change the value. I'm going to go with D. And our last one. Oh boy, I bet you came just to see this one. Use the information in the table to solve each problem. Use estimation to check answer parts A and B. What is the combined length of pine and elm? Round to the nearest whole number to estimate. So the combined length of 7.6 and 8.9. Let's do that now. 7.6 and 8.9. I'm going to combine those and get 16 and 5/10. So we'll put 16 and 5/10. Notice that 7.6 is 7.6 closer to 7 or 8? Well, it's closer to 8 because this right here, that 6 is 5 or greater, which rounds it up to 8. And 8.9 is about That's about what, 8 or 9? That's right, 9. So the estimated sum, so we're going to add 8 plus 9 is 17. The answer, so is set, guys, is 17 close to 16.5? What do you guys think? Yes, it is reasonable because 16.5 is close to the estimated sum of 17. The difference in length is 16.5 minus 7.7 kilometers, which is what? Well, let's figure that out. Did you toot, Huddy?
No.
Oh. I got 8.8, guys. Notice that 16.5, is that closer to 16 or 17? That's right, it's closer to 17. And 7.7, is that closer to 7 or 8? Yeah, that's right, it's closer to 8. And so the estimated difference means subtraction. 17 minus 8 is 9. The answer is 8.8 close to 9? Yes, so the answer is reasonable because 8.8 is close to the estimated difference of 9.
Freddy made this for me.
That's cool, guys. You want to say hi?
Salt and bread.
Oh, you didn't put too much salt on, did you?
Hi.
Oh, crumbs getting everywhere. Well, that's it for today, guys. Keep doing your math and come back to visit to learn more about Envision 6th grade math. My name is Jason Jacobs, and we were learning how to add, subtract, multiply. And next time, we're going to learn how to divide with decimals. I'll see you later, guys. Toodaloo. Bye-bye.